Hi everybody, this is Julian from Arcee. I hope you like my summertime office. I know I do. In this video, I'd like to talk about a new model built by Arcee. It's called Arcee Lite. It's a 1.5 billion parameter model, so definitely a small one. And this model is a little bit special because it was built with a new open source library from Arcee called Distilkit. And as you can guess from the name, Distilkit is a model distillation library. We'll talk a little bit about that, but I'll cover Distilkit in more detail in a future video. For now, I just want to show you Arcee Lite, this really sweet 1.5 billion parameter model, first running locally on my machine and then deployed on AWS with Amazon SageMaker. Okay, let's get started. Of course, you can find the Arcee Lite model on the Hugging Face Hub, and as usual, I'll put all the links in the video description. So let's take a look. Arcee Lite is a compact yet powerful 1.5B parameter language model developed as part of the Distilkit open source project. Okay, and again, feel free to go take a look at the Distilkit project on GitHub. We'll cover that stuff in more detail later. So distillation is basically a process where we start from a larger model, and in this case, the team started from Phi3 medium, which is a 14 billion parameter model, and you run it through that distillation process, and you distill it into that 1.5 billion parameter model, which is actually based on the Qwen 2 1.5B architecture. So about let's say almost a 10x size reduction from 14 billion to 1.5 billion. And the magic of distillation is we're trying, although we're slashing parameter count by almost 10x, we're trying to keep as much of the good stuff as we can. And you can see this in the benchmarks. So let me zoom in a tiny bit. Right, so what's particularly interesting here is the comparison between the yellow bar, which is Qwen 2 1.5B instruct, and Arcee Lite. So same architecture, except the weights come from distilling Phi3 medium, so 14 billion. And we can see that across the board, Big Bench Hard and multi-step reasoning and MMLU Pro, although the models have the same size, same parameter count, the distilled model is performing much better, right? Much better. And Qwen 2 1.5 is actually a very good model. If we look at the SLM leaderboard, at the time of recording, it's actually the best 1.5B model available, right? Well, I guess I should say Arcee Lite is now the best 1.5B model available. Okay, it shows how powerful distillation is. You can start from a much larger model, shrink it by almost 10x in this case, and outperform the best in class, right? For that size 1.5, right? So again, we'll dive deeper into distillation another day, but just goes to show it's a good technique. Okay, why don't we start by running this thing locally? So I believe we have, yes, GDUF versions available. So I just grabbed the 8-bit version here, right? I just click on this and download it, right? Sometimes some of you complain that you're skipping steps. So fair enough. So not skipping steps this time, downloading this one, okay? And honestly, we could probably go lower, but because it is already a small model, I thought, why don't I stick with the 8-bit version? But yeah, feel free to try the 654. They're even smaller, right? So if you have a constrained environment, if you want to run this maybe on your phone, why not? These are good choices. Okay, anyway, I'll go with the 8-bit version. So I imported it to Ollama, and I'm using the OpenWeb UI here. Okay, so let's ask a question. I'm not so interested in the result. I just want to know how fast this is. Wow, look at that. This thing is flying. Okay, so now you see the first benefit of a small model. It's just faster, right? It's, well, if it's 1.5 billion parameters in 8-bit, it's 1.5 gigabytes. We can run this on the even a small machine. I haven't tried CPU inference, but it should be, it should be okay. And here, if you have a nice machine, then of course it runs even faster. So that's the kind of speed. That's the kind of speed you can get, right? So I haven't looked at tokens per second here, but it's certainly well, the fastest I've seen on my local machine. So that's a good first step, right? If you want to run this model locally, there you go. Grab a GGUF version here, download it, import it to Ollama, and then yeah, you can query it all day. Nice. Now, of course, for production, you may want to deploy this thing in the cloud. So let's look at how we would do this on Amazon. And of course, I'm going to use Amazon SageMaker here. Okay. Again, you'll get the sample notebook. Let me zoom in a tiny bit. And let's run this. Okay. Basic dependencies, as usual. And well, pointing at the Hugging Face repo. And I'm actually using the smallest possible GPU instance on AWS, G5 X large, which is, really the smallest, least expensive one you can get, because it is a tiny model. Then again, I should really try CPU inference. Maybe that's another video. I need to try it first. Hopefully it doesn't suck. Okay, the environment for our deployment inference server, which is, of course, Hugging Face TGI as usual, model ID, 1 GPU on this instance, and I'm enabling the OpenAI messages API so that we can predict with the model using OpenAI syntax, which is quite comfortable. Okay, create a model object with the latest TGI container 2.2, then call deploy, wait for a few minutes. We have our endpoint. Okay, so now we have a proper production GPU. So let's see how fast this is. Okay, so let's just send this prompt and let's run it. And I'm timing it, so let's see how fast we are. Okay, so synchronous inference first. Okay, so long answer. So we did 461 tokens in 4 seconds 20. Okay, so, well, I don't need my calculator. It's 100 plus. Okay, 110 maybe. So 110 tokens per second is on the tiniest GPU instance is a very good number, right? So that instance costs, I think, $1 an hour on demand. Okay, so you can run that model at scale for, silly cheap, honestly. Okay, now let's try maybe streaming inference. And remember, all we have to do is set streaming to true here in the TGI container, and bam. Oh, that was a short answer. Come on, you can do better. Yes. And that's fast, right? That's very fast. No one can read that fast. That's my benchmark. Okay, so then again, you see, right, how fast you can run this. And keep in mind, that's a single GPU. That's a tiny machine. It's not even the latest GPU. So if you need to scale things up, you can, right? So what would you use that model for? It's probably a good way to end this video. So it's only 1.5B, even though we started from a really good model. It's just a limited amount of knowledge. So I wouldn't use this for, I would say general purpose Q&A as is. It's probably a bit limited. But if you start plugging external context, it's certainly going to do very well. So as a RAG model, this is very, very tempting. Okay, and in fact, I just have a small example here, which is not really RAG, but I'm adding extra context. It's the machine learning Wikipedia page, and I'm asking a question. Is Cybertron the ancestor of deep learning? And we get a good answer. And go check out the Wikipedia page for machine learning, where they talk about Cybertron, this machine developed by Raytheon in the 50s, etc. So that's exactly the right answer here. So as a RAG model, this is probably good. I would really try that out instead of your 7B model. Try this baby, see how it runs, because the tokens per second you get here are impressive, and your ROI is just going to shoot up. I mean, even if you still deploy on the same GPU instance, the throughput and that you're going to get from that 1.5B model is going to be much, much higher than your 7B model. And as we know, in RAG architectures, the model is really just a writing assistant. The knowledge comes from the external source of truth, right? You probably heard me say that a million times and you get tired of it, but it's real. In RAG, the model knowledge is not so important. The good stuff comes from the documents that you stored in your RAG data source. So that's probably a good one, a good use case. The second use case would be, of course, embedded, especially if you go and start looking at those tinier versions, like maybe if we look at this one, Q4KS, that's gonna be small. That's gonna be really small. It's just gonna be a few bits per parameter, so it's gonna be under a gig for sure. So you could fit this thing anywhere. You could fit this thing on a phone. You could fit this thing on any kind of constrained device. And it would probably still do a very good job at language modeling. Okay, so I love those tiny models. I think they pack a ton of punch. You can run them for silly cheap, and they still do a very, very good job on the language modeling, right? And that's thanks to distillation, which we'll cover soon enough. Okay, well, that's really what I wanted to tell you today. And before I jump into the swimming pool, my friends, you know what to do. Keep rocking.